Next up, we've got Sudarshan Samarasinghar. He's going to tell us today about how teams can make UAVs more reliable under challenging conditions in critical rescue missions where things may not go to plan. Put your hands together for Sudarshan.
Let me tell you a dramatic rescue story. Tony, his friends, and his dog Benji go on a huge hike in the Grampians on a beautiful sunny day. Suddenly, typical of Victorian weather, there is a huge storm. In the rush, Tony falls and injures himself. The rescue team can't get to him because of the rising flood water. In comes our drones. Drones are cheap, easy to use, and a large group of them can work well together to solve complex problems. If you didn't know already, the New South Wales Fire and Rescue Team now use drones in difficult rescue operations. But while the single drones that they use may be able to carry smaller objects, my research focuses on how a large group of drones can solve difficult problems. For example, carry all this food and medicine for Tony and his friends, and even that special treat for Benji. If you have used drones before, you know that they can be extremely fragile. While going in the wind and the rain, a motor can get burnt, and we call this a fault event. When a fault event occurs, it can disturb the drone, causing all this to come crashing down. How do you stop this? This is what I will tell you. Let's say you're carrying a tray of drinks in both your hands. Suddenly, your right hand cramps and you let go. Now your left hand must flex harder to restore that force that your right hand was providing. Restore. When a fault event occurs, the drone must automatically estimate the power loss and restore that force so that there is no disturbance to the load. To solve this autonomously, I am considering all the sensor feedback and developing control algorithms that will allow the drone to estimate the power loss and restore that force. Using my research, I have been able to reduce the disturbance on the load by up to 90% compared to existing methods. But let's say you didn't go to gym that week and you can't flex hard enough. Then reconfigure. The other healthy drones in the formation can reconfigure themselves so that they carry more of the weight while the affected drone takes a break. To do this, I am considering all the force data to allow the drones to calculate the best position in the formation with respect to the force they can provide. Finally, using these methods, we can resolve the problem and get all that food and medicine to Tony so he and Benji can go hike another day.